Hi all, good evening. So I will start in a couple of minutes. Let's wait if someone else join also. Okay, so let's start. I will just start the recording.
This call is now being recorded.
Okay, so am I audible and my screen is visible?
Yes, ma'am.
Okay. Okay, so before we start with some more concepts, Let's take one question based on the session that we had yesterday. Okay. So the question is your input xt to the system. So this is the system and get the yt as output, y of t. This is your output and your input is nothing but a unit step signal. Okay. And now your system has impulse response as h1t plus h2t, means two of the impulse responses being cascaded, okay, in series, h1t plus h2t. Now you have h1 of t as given um 2 delta t plus 2, and h2 of t is given as say, I can take this as minus 3 delta t plus 1. Okay, so this is your h1t and h2t, and you have to find energy of yt. So everybody try for few minutes and then I will let you know like how it is being solved. Okay, okay. There's one correction. Just a minute. So your H1T is altogether like 2 delta T plus 2 minus 3 delta T plus 1, and your H2T is simply delta T minus 2. Now, sorry. YT is equal to what? X of T convolved with
H1 of t
H2,
plus H2 of t.
H2 of T. Now xt, you know, it's ut. Now it's convolved with these functions like 2 delta t plus 2 minus 3 delta t plus 1 plus delta t minus 2. So what will be your approach to solve this?
First, we can multiply this u of t inside this whole thing. Then
Okay.
we can apply that formula
We use
x of
distributive function.
Yes. Yes. Right. So yeah, so we will multiply that is the distributive function. So that means ut will be separately multiplied with this and this. So delta t plus 2, okay, and you can write it. So
and
we'll
we can
just
also
break
just
this.
simply multiply this u of t in all these things because
Yes, yes, yes. Yeah, I'm doing that. So ut delta t plus 2 minus ut minus 3ut delta t plus 1 plus ut delta t minus 2. Okay, now quickly tell me what will be the answer for this.
So it would be 2 u t plus 2 minus 3 of u t plus 1 and plus u of t minus 2.
Okay, so
Basically,
2
we just replace the delta with u in every term.
yes. So 3u t plus 1 and then plus u of t minus 2. Okay, so 2ut plus 2 minus 3ut plus 1. And so I hope everybody gets this answer, right?
Excuse me, ma'am.
Yeah.
That delta would be written here, right? Because we still haven't did the integration.
Uh, so the function, yeah, so actually, yes, yes. So that thing is there. So it's basically convolution, no? So yeah. So this is so this is basically minus infinity to infinity. So this is convolution, no, not simple multiplication. So ut convolved with this and ut convolved with this. So this we get finally after the convolution. So based on that property only. Okay, so I missed that step. But that is the convolution thing happening, not the simple multiplication. So we'll get 2ut plus 2 minus 3ut plus 1 and ut minus 2. Now, the question is you have to find the energy of this y of t. So how will you find this?
We can plot this in a graph and then we can find it.
Exactly, right. So we will be plotting this u of t, u of t. So this is t, this is, sorry, this is y of, so we will be plotting this y of t here, and then then it will be easier for us to calculate the energy. So 2ut plus 2, so that means the scale is 2 and it's minus 2, it's starting from here. And then what is the next break? That is plus 1, so that means minus 1. And you are going 3 down. So 2 and then one more. So like this. So it will be minus 1 over here. And then till where? Minus 2, that means here 2. So, so it's minus, so it's plus, that means plus 1. So we are going to till this 0 and then straight line. Yes. So this
Yes,
will
ma'am.
be the right. So this will be the graph. Now you can easily find the energy either by just uh, looking into this. What will be the energy? This is 2, this is 1, and this is
7.
very good. Yes, it's 7. So here it's 0. Then we have 2 into 1. So 2 into, yeah. So it's from minus 1 to minus 2. So it will be t minus 2 to minus 1 and then plus t minus 1 to 2 plus 0. So it will be comes out to be 7 and it's the energy. So it's joule. Okay, so this was the question. So this is like to give idea, like you started with very recent topic what we have studied about the cascading, and then we have utilized the property over here, and then we have used another property, direct delta function property over here, and then we have gone back to the initial lectures where we used to plot the signal. So we plotted the signal, we calculate the energy. So you can see that it's combination of many lectures included in one question. So it's type of good question you can expect in like some end term or something. Means it's just a combination of the uh, many chapters. Okay. So now, so yesterday I have for the LTI system, we have discussed what we have discussed convolution. We have discussed properties, and we have discussed the delta function on convolution. So now today we will start with some more properties of not the properties but about the system. So when we say that the system is whenever we say when the system is LTI, okay, so the system is LTI, then that means your output is always and always equals to input convolved with the impulse response of the system. Okay, that's true for every LTI system. So if the system is LTI, we will always say that the output is input convolved with impulse response. True. So now, uh, so every LTI system has some impulse response. Now we can also say that based on the characteristics of the impulse response, we can tell about the system. Okay, just by knowing the impulse response of the system, we can say whether this system is stable, is it invertible, is it causal, is it memoryless, and everything. Okay, so you must have gone through the lectures. I will just give a brief and then we can solve some examples. So for okay, so if you have gone through the lecture, anybody can tell when can you say that the LTI system is memoryless?
When it's not depending on the past and future inputs.
Yes, that's true. It doesn't depend on past, but how can you say based on the impulse response of the LTI system? So that is for any system. Okay. So any system that doesn't depend on past or future, it's memoryless. Now, if you have the LTI system and I say that, okay, this is memoryless, then what should you expect about the impulse response of that system?
At delta zero,
Delta zero,
Right.
delta zero is
or like
like
if the function is depends on t, so delta t, there should be not like t minus 1 or t plus 2. uh, the shifting should not be
okay,
there with delta.
in delta, like
Yeah.
a delta function, right?
Yes.
Okay,
Yes.
so yeah. So the thing, okay, so you are correct. So based on the impulse response, so the impulse response that is ht of the system should be any constant a multiplied with this delta t. Anything apart from this will result in a memory based system. Okay, if and only if your impulse response is a delta t, that means a constant multiplied with the delta function, then only it can result in a memory less system. Otherwise, it will always be a memory based system. Okay, so this you must have learned in the video lecture that have been shared on the portal. So, did you understand the logic behind this? Like, why is it so? I think Sir has explained with some example, taking the area and all. So, are you good with it, or do you want me to discuss that?
It was clear for me.
Yeah, sorry. I think two
I,
people. Yeah, you
uh,
can go
uh,
one by one. Ananya?
I said it is clear for me.
Okay. So, for those who want the explanation, can just put a thumbs up, and if all are good, then we can proceed further. Okay, so everybody understood the logic behind why the ht is equal to a delta t, and other than that will result in a memory based system, right? So this is one. Now the second is causality. Okay, so following the lecture, can you tell me when, what type of impulse response should lead to a causal system? So, causal system means it depends on past and present, but it should not depend on the future value. Okay, so if some of the system, the output is depending on the future value, then it's a non-causal system. Now, based on the impulse response, what characteristics should this impulse response have to make it a causal system, causal LTI system?
Delta t minus t.
Delta T minus T.
Like delta t minus t naught means the minus shifting could be there, but not but we cannot consider about the plus shifting, means not the future shiftings.
Okay, not the future shiftings. As in, so firstly, tell me whether it should be a delta function or any function can be okay
Causal.
for the causal.
Any function could be
And
causal. Any function could be causal, but it should not
Huh?
depend on the future inputs.
Okay, and then how should we make sure that it should not depend on the future input? So,
Uh,
how will you plot this HT to make it a causal system?
it should start from minus infinity to 0.
Zero to
Basically, it would
infinity.
be like when we provide some input, it should just not depend on future.
Yeah.
So,
Yes. So,
or one
huh,
example I can give, that UT is a causal system. You like unit step is a causal system, or a causal.
unit step. Okay, so that means you're saying that if your HT, the impulse response of that LTI system is UT, that is this function, then you can say that any input, means xt can be anything, applied to this impulse response will result in yt, that is a causal, right?
Yes.
Yes, so that is true, but how should you means represent this? That for so the ht should be a function such that ht is equals to 0 for all the values of t lesser than 0. Means there should not be a non-zero value when t is less than 0. Okay, it should always start from 0 and then proceed, but there should be all 0 elements when t is less than 0. Clear? So if okay, so let's take one example. um, I have this function. I have this function. I this function. So all are ht. Okay, so one by one, let's go. So whether the LTI system for impulse response this will be causal or non-causal?
Ma'am, which one?
This first one. This one.
The first one is mm, the first one is causal. Yes, ma'am, causal.
Causal? Are you sure? Non-causal.
Sorry, no, not causal. Yeah, it's lying on both sides.
Right. So there are non-zero values when t is less than 0. Okay. So this is non-causal. Now this, the second one. Is this causal
It's
or
causal.
non-causal?
It's causal because the t
Right.
is this is ht is non-zero for t greater than 0.
Correct. So this is causal. Now the third one.
Non-causal.
Very good. Non-causal because it again has non-zero elements in this left part, left side. Okay. Fourth one. Unit ramp signal. Causal.
Causal. Yes, ma'am.
Ma'am, causal.
Right. It is causal. Now the fifth one. So it's again a decaying signal starting from 0 and decaying, and here it's also
Non-causal.
decaying.
Non-causal.
Very good. So although it's decreasing with time, but at certain point of time, there are elements that are non-zero with for t less than 0. Then it's clearly a non-causal signal, non-causal system. Okay, so now you're good with any system, any LTI system, where it's stating that you just simply quickly plot your impulse response and check. Okay, so t less than 0, you're getting some value. Immediately, it's a non-causal system. And um, if some system has some zero, all zero values, then it's clearly a causal system. Okay, and for memoryless, it's even easy. You immediately just have to check whether it's a delta function or not. That's it. Okay, of some it can have some constant for sure, but it should be a delta function. Okay, these two are done. So then we can move to invertibility. Okay, so invertibility, I will explain this, and so this you will not be able to like figure out fully in this present lecture. But when we will move to the Fourier transform now, you will get invertibility concept more clearly, and you will be able to find out the inverse functions for some system. But as long as we are not familiar with Fourier transform, I will just give a brief about invertibility, like what is invertibility and for LTI system. But full and fledged, you can understand when once you get the concept of Fourier. Okay, so invertibility. Okay, invertibility. You must have done for general system. What do you understand by invertible when the system is invertible?
When input has different output, no input has same output.
No, that means like if
Right, right.
it's right. Okay, means for me it's like
But
when
you,
your output yt is like
hmm
depends on xt, with the system ht, but when you take h inverse of t, for h inverse of t, for the same input like
Hmm.
yt, I should get xt.
Okay. So yeah, so both are saying the same thing. So Ananya was telling in terms of mapping. So I will show it with some figure. Okay. So it has input x1, x2, x3. Okay. And then it goes to a system because there can be multiple inputs. And then we have output, we have y1, y2, y3. Okay. So one way to understand invertibility is when in each single input is mapped to a single output, nothing else. Okay. So this x1, whenever you have an input as x1, you should get the output as y1. Okay. And if your input is x2, then you should exclusively get y2 as output. If you have x3 as input, you should exclusively get y3 as output. Okay. So then this system can be called as invertible. Okay. And Pratham, as you were saying, so when we reverse it, means when we put a reverse system like output process through S inverse, it should result in input. Okay, so this is like one way of telling, but invertibility is only and only possible when each input is when the output is exclusive of input. Means one input results in one output. Suppose for an example, yt is equal to mod of xt. Is it invertible or means invertible or non-invertible?
Yes, it's invertible.
Okay, are you sure?
This systems only, no? Yeah.
Hmm. Okay. Anybody else with some different answer? Somebody has a feeling if it's non-invertible. Okay, everybody is agreeing that it's invertible. Okay, let's find out.
Ma'am,
So
since like system is linear, so this thing is invertible only.
yeah, so the linearity is okay followed, but we have to also, that's why I have started with this. We have to very carefully look into this condition as well. Like each input should be matched to its exclusive output, not okay. So in what happens in non-invertible? Then your one output can be mapped to two inputs. Okay. So x1 can also result in y1 and x2 can also result in y1. Then when you are going to invert, so y1, when it's put in inverse of system inverse, then then it will be confusing, na? Whether it will be x1 or x2, because both are resulting in y1. Okay, so then you can't say. Then the system becomes non-invertible, right? So now, if I take my xt as suppose +1, okay, then what will be yt? Mod of +1 is equals to +1. Now, if I take xt is equal to -1, now my yt is equals to mod operator on this value -1. Then again it's +1. So yt is giving 1 for 2 values of input. So definitely it's a non-invertible system. Okay. Now I will take another example. Yt is equals to x of t minus 2. Is it what invertible or non-invertible? Non-invertible.
Yes, it's invertible.
Okay. Right.
On adding,
Invertible.
on adding to both sides, it becomes invertible.
Yes. Because for each value of t, you will have a different value of your output. Now tell me yt is equals to t square. Now tell me, is it
Not
invertible or
invert.
non-invertible?
Not invert.
Non-invertible. Yes. Because your now my output is no longer exclusive of my input. Okay, so this is the criteria to check whether the system is invertible or not invertible. Now coming back to invertibility of LTI system. So invertibility of LTI system. Okay, so again we have this input xt, we pass it through S, that is some LTI system with impulse response h1 of t. So we again pass it to another, so this is S1, another system S2, which has your say impulse response as h2 of 2. That again results back output yt as x of t. So then we can say that my this LTI system is invert. But how will you know based on these impulse responses? So the condition is, so okay, so let's prove it. Okay, xt. So now you have to do the convolution. So convolution of h1 of t convolved with h2 of t, that results in xt only. So, any idea, any guess that what should this result in? Means H1T convolved with H2T, what should be equal to this such that XT convolved with whatever we get here is equals to XT only?
We can directly write ht. And like h1 convolving with h2, simply we can consider as ht.
Uh, so, what will be the value for this HT? Means ht can be anything, no? So
Yeah,
what function should be here? So there could be only one function possible to make this equation true. Now tell me.
Delta T.
Delta t.
Uh,
Very good. So we have discussed this formula, right? Xt convolution with delta t minus t naught is equals to x of t minus t naught. So that means if you put t naught equals to 0, then xt convolved with delta t is equals to x of t. That means this h1t convolution with h2t should be equal to delta t. Or we can write it as h1t convolved with h1 inverse of t is equals to delta t. Okay, now you know that how are we getting this as delta t, h1t convolved with h2t. Okay, so now for now you should you may not expect like some h1t is given. Now you have to find this inverse, because now you don't know the tool to find out this inverse. Okay, so such type of question will not come, so don't worry about that. But once we are familiar with Fourier in the future lectures, then we can again come back to this for solving this inverse. Okay, till now only this property and this condition you can familiarize and just recall when some questions based on this are asked, but not other than this. Okay, clear with invertibility.
Yes.
Okay. Okay. So now, last one is your stability. Okay. So stability of a system, right? So can anybody just give a brief about what do you know about stability when the system is stable?
When we give a bounded input and we get bounded output.
Correct. So Bibo stability. So for any bounded input, we get a bounded output. Okay. So now coming back to stability of LTI system. So LTI system means again we have this impulse response. Now, what characteristic should this satisfy, or what condition should this HT satisfy to make it a stable system? So this we are assuming that we are giving a bounded input signal. Okay, then only we can check this Bibo stability criteria. Means we are assuming, so for all checking the stability of LTI system, we are always assuming that my XT is bounded input. Okay, so we are giving a bounded input signal, not infinite type signal. So then what condition should this HT satisfy to make this a stable system? So the condition is anybody can want to answer this? What condition should this HT satisfy? Okay, so HT, uh, yeah, anybody? Okay,
Means
so
what condition are you asking? Means I was
means like uh, HT. So what condition means anything related to impulse response, like impulse response should have some criteria, then only we can say that the system is Bibo stable. So can you tell me what should be the characteristic for this impulse response? Like what type of impulse response will result in a stable system?
means it should not diverges at infinite. It should converge. The function should
Yeah.
converge.
Yes. So you're yeah, partially correct. So it's like when you integrate the mod of ht from minus infinity to infinity, then dt, then it should be less than infinity. Means when you integrate your impulse response, it should have a finite value, not infinite value. Okay, so let me ask some questions. So, if suppose your HT is some periodic signal, so we can take it as sinusoidal. So now, if you apply some bounded input xt, okay, maybe a rectangular function. So then, can you tell whether it will be stable or unstable?
Unstable.
Correct. So
No,
any
this is stable.
period.
This is
What?
stable. It's YT is stable for HT if you are asking.
So your HT is infinite. Okay. For infinite time, it's oscillating. So it's not bound. Means when you integrate this, so you will not get a finite value, right?
Okay.
So that means this is an this is unstable system. Okay, let's consider one more example. Then it will be more clear. So now you have your HT as this function. So this has also been taught in your lectures. So now by knowing this as your impulse response, can you tell me whether it will be a stable system or not?
It will be stable because it is converging to 0.
Okay, so does somebody feel something different, like a unstable? Okay, yes. So this is stable because when you will integrate this minus infinity to infinity e to the power, so this is nothing but e to the power okay, so this is minus of mod t dt. So when you will this integrate this, you will have a finite value. So you can say that this is a stable system. Okay, let's try one more example. So this time, so for this you have to tell me. Okay, let me draw first.
Unstable.
Okay, and now so now is it stable or unstable?
I think it's still unstable because it is coming from minus infinity. It's doesn't feel like that it is going to 0.
Okay, but it's decaying. So when you so this is this function when you write it mathematically, so ht is equals to e to the power 2t and u of 1 minus t. Okay, so this is your ht. Okay, so when you will try to integrate this minus infinity to, so this is value 2. So 2 e to the power 2. So 1 minus, so sorry, this is 1. So u of 1 minus t will result. So this is nothing but your limits are going from where to where?
Minus infinity to 1.
Right. Okay. So this, when you integrate this, what will be the output that you will be getting? Everybody can please solve and
E to t by 2.
hmm, hmm,
Then we
correct.
can integrate.
Half, yes, half e to the power 2. And this is some finite value which is less than infinity. So HT is converging, means it's finite. So then the system is stable. Okay. So be very careful. So you have to check, okay, whether it's uh, stable or not. Okay, for this question only, can you tell me whether it's memory or memory less?
It is memory less. Sorry, it's not memory less.
Okay, then it's a memory system based on memory.
Yes, ma'am.
Correct. Why? Because so this is very simple. Okay, straightforward. When HT is not an impulse delta function, then simply it's a memory system. Okay, so this is fine. So this is stable. This has a memory. What about causality? Is it causal or non-causal?
Ma'am, non-causal.
Very good. Non-causal because it has values in the left hand side of the y-axis. So it's non-causal. Uh, Invertibility. So for now, just letting you know that it's invertible, but yeah, it's perfectly fine. So we will do it once we are familiar with the Fourier series. Okay.
Ma'am,
Yes.
I had one question. There was one
Hmm.
question like y of t is equals to x of t multiply cos omega t, and it was said that it is Bibo stable. I couldn't get it. How?
Mm-hmm.
Yes,
Because
actually, cos omega, like sinusoidal functions are stable. Therefore, I just said that oscillation one is stable because yt is not going to infinite, xt is going to infinite.
Okay. So
yes, ma'am.
it is in one of the lectures of professor, right?
Ma'am, it's an activity. This question.
Its activity also, and in one of the live lectures, I guess that Ankita ma'am has discussed that.
Okay. So now, okay. So what is that? Like yt is equal to
Just we can take cos omega.
X of t.
x of t convolved with cos omega t.
Yes, ma'am.
I guess it's not
It's I
convolved,
guess
it's multiplication.
yes.
Only multiplication, not
But
convolution.
okay, xt cos omega t. This one?
Yeah.
Okay. So now what do we have to tell, like whether the system is stable or not?
Yeah, only
Yes.
stable.
Okay. So for stability, we know that so xt is some function and it's multiplied with cos omega t. So cos omega t is periodic. That means it's going infinitely.
Yes.
So infinitely, that means the system is unstable. So
But ma'am, its amplitude is bounded, and that was the answer. This is the sinusoidal functions are the stable that we know. Like the cos omega t, it's bounded to plus one to minus one only. So whether its time axis is infinite, but this is
hmm,
bounded because if we take integration, it will come sine omega t only. So
yes, it will come sine omega t. Uh, okay, about stability or other things also, like in you have doubt regarding the stability, right?
yeah,
Only the stability part, like
but
whether this
it's like
whether
if it's tan, if tan is there, then it's unstable
huh,
because the tan will go from minus infinite to infinite
infinite.
in the
Yeah,
y-axis. But the
right,
x
right.
and sorry x, the sine and cos remains minus one to one only. That was it.
Okay. So
Uh,
if yes,
but ma'am, when we did the convolution just now, then it was said that it's unstable.
Hmm. So convolution. Yeah. So let me first come to this. So general system and the convolution. So convolution, whenever there is a convolution, okay. So that means what I'm trying to say is I will come to this point, but let me first tell you the difference because it's a bit confusing. But simply, whenever there's a convolution happening, no, so some input is convolved and your system is a sinusoid. Okay, this is also sinusoid cos omega t. So your system has this sinusoid and your xt is given to this, and you have to find the out, means you have to tell whether the system is stable or not. So as long as the system is LTI, okay. So for LTI means the convolution has happening, that means it's LTI system. And for LTI system, always and always there is only one condition, that is your uh, this this condition. Okay, your HT, where I have written, your HT integration should be finite value. Okay, this is the only condition. So when you see this cos omega t, so it's expanding, like, yeah, it's oscillating, but it's going from minus infinity to infinity. Okay, so that means this function becomes unstable, right? So
Yeah.
now,
Okay, ma'am. Got it.
yeah, so this is this, I think, in lecture, I guess, 7. So I just suggest you to very carefully go through lecture 7 of this week, week 6. Okay, so sir has also explained this part, like why should it be unstable. So cos, and for the general system. Okay, so this is the part for the convolution, that means for the LTI. So look very carefully in the question whether it's a general system asked, means nothing related to convolution or LTI. It's just simply some yt is equals to cos omega t, or yt is equals to uh, xt cos omega t. Okay, so this is again, so this may not be LTI system, because LTI system has to be always a convolution with the impulse response and not the multiplication. Okay, so then for this I need to check. Okay, so I can check and get back to you in the G space, so it's a bit confusing. But for LTI
Uh,
system, yes,
yes, ma'am, I got it because it would be moving permanently, continuously, and it would be
mhm,
taking at it would be taking the output at every point, so it will
yes,
not stop ever if once
yes.
it start.
Right. So T is infinite duration. So it's always continuous from minus infinity to infinity. And you cannot say that it will have a bounded output, right? Whatever be the xt, that means it's unstable. Okay, so now I hope that week 6 assignment, a graded assignment, you will not have any difficulty. So if you want to discuss few any point or any doubt, you can discuss. So this is all from my side for today's session. So now we can just stop the streaming and just take some doubts if you have any regarding assignment or something. But if you see now, your assignment is very